Hello everyone and welcome to the Mathmetecher channel. Let's suppose that n is a natural number. We would like, at first, to find out the remainders of the Euclidean division of each of 3 to the power of n, and 5 to the power of n, over 7, according to the values of n. Then, we want to deduce the remainder of the Euclidean division of 5 to the power of 1445, all to the power of 2024, over 7. So, let's start by finding the remainder of the Euclidean division of 3 to the power of n and 5 to the power of n, over 7. By using the concept of congruence, as 3 to the power of 0 equals 1, then 3 to the power of 0 is congruent to 1 modulo 7. Then, we have 3 to the power of 1 that equals 3, which is congruent to 3 modulo 7. After that, we have 3 to the power of 2 that equals 9, which is congruent to 2 modulo 7. Then, we have 3 to the power of 3, which equals 27, that's congruent to 6 modulo 7. Then, we have 3 to the power of 4, which equals 81, that is congruent to 4 modulo 7. After that, we have 3 to the power of 5, which equals 243, that is congruent to 5 modulo 7. And finally, if we calculate 3 to the power of 6, we find that it is equal to 729, which is congruent to 1 modulo 7. So, as this last congruence is the same as the first one, we deduce that the congruences of the powers of 3 modulo 7 form a periodic sequence of period 6. Now, let's check out the powers of 5. So, at first, we have 5 to the power of 0 which equals 1, is congruent to 1 modulo 7. Then, we have 5 to the power of 1 that equals 5, which is congruent to 5 modulo 7. After that, we have 5 to the power of 2 which equals 25, that is congruent to 4 modulo 7. Then we have 5 to the power of 3 that equals 125, which is congruent to 6 modulo 7. After that, we have 5 to the power of 4 that equals 625, which is congruent to 2 modulo 7. Then, we have 5 to the power of 5 which equals 3125, that is congruent to 3 modulo 7. And finally, when calculating 5 to the power of 6, we find that it equals 15,625, which is congruent to 1 modulo 7. So, as it is the case with the powers of 3, the congruences of the powers of 5 modulo 7 form a periodic sequence of period 6. In the following table, we resume the remainders of the congruences of these two sequences of powers modulo 7. Now, let's deduce the remainder of the Euclidean division of 5 to the power of 1445, all to the power of 2024, over 7. So, as 5 to the power of 1445 can be written as equal to 5 to the power of 6 times 240 plus 5, we deduce, according to the table, that this power of 5 fit into the value 6k plus 5 for n, which mean that 5 to the power of 1445 is congruent to 3 modulo 7. Moreover, as 3 to the power of 2024 can be written as equal to 3 to the power of 6 times 337 plus 2, we deduce according to the table that this power of 3 fit into the value 6k plus 2 for n, which mean that 3 to the power of 2024 is congruent to 2 modulo 7. So, 5 to the power of 1445, all to the power of 2024, is congruent to 2 modulo 7. Therefore the remainder of the Euclidean division of 5 to the power of 1445, all to the power of 2024, over 7, is 2. As always, thank you for watching. Subscribe to the channel and like and share the video. And until the next one, have a great time.